Alright, so on 3B, let's start with our domain. How do we find the domain again?
You pull denominator.
Denominator cannot equal 0. So we know that means that x cannot equal 2. So my domain is going to be?
Negative infinity to u to infinity.
Good. Alright, now, before I can move on, I need to try to factor that numerator. So, because I can't tell if anything cancels unless my numerator is factored out. So we have, I'm just going to write it here. It's a 2x squared minus 3x plus 5. Remember to factor. You're going to do the multiplying. So you get x squared minus 3x plus 10.
Negative, oh wait.
So does
It doesn't.
anything multiplied to 10 that'll add to 3?
Yes.
No. So it just means it's not factorable.
2 and 5.
They don't add to 3, they add to 7.
Like 2 5.
Yeah, it has to
But
be
if you do
negative.
well,
You can't do it.
if you do a negative 5 and a plus 2, but that would
If you do 3
do a
times
negative.
That gives me a negative 10 at the end, right? So that doesn't work.
I see the problem.
That's why, if you notice, I don't say it has to combine to be 3, which I know some of y'all do say that. I actually read it backwards. I say it has to multiply to 10, and whatever sign that is, it works every time, guys, is what you're going to do to get to that middle number. So it needs to add to 3. So I'm not even thinking 5 minus 2. I'm thinking 1 plus 10, 2 plus 5. None of those are 3. So therefore, this is not factorable. So, in that case, do I have any holes?
No.
No, because nothing can cancel because it's not factorable, right?
So all that was for nothing?
No, not for nothing.
Or are you just showing us how to check it?
Well, I was showing you how to try to factor it.
Okay, so but why did you only do 2 times 5 and not 2 times negative 3 and 5? The negative 3x.
Oh, because that's just how you factor a trinomial. Remember, you take that first number and you multiply it times the last.
Oh, okay.
Okay, that's why I wasn't distributing or anything. I was just working out factoring that trinomial.
Okay.
All right, so then, do I have any vertical asymptotes? Do I have any uncanceled factors in the denominator?
No.
Yes, that x minus 2 didn't cancel, did it?
I wasn't.
So that means I have a vertical asymptote at x equals 2. Now, we're going to come back to slant asymptote. Actually, no, let's go ahead and do slant asymptote now.
Wait, how'd you use the vertical one time?
Uncanceled factors of the denominator set equal to 0.
Okay.
So basically, it's the restrictions in the domain that are not holes.
Oh, okay.
Okay? So, slant asymptote. Notice they didn't ask us about a horizontal asymptote this time, okay? Because you cannot have a slant and a horizontal asymptote. You're going to have one or the other or neither, but never, ever, ever both. And that's because the only way you can have a slant asymptote is if the degree of the numerator is greater than the degree of the denominator by 1. So I'm going to move that by 1 over. So because the degree is going to be bigger on top, that means there's no slant the degree of the numerator is bigger on top. That means there's no horizontal asymptote. But then you have to ask yourself, is it by 1? If it is, then there's a slant asymptote. So look at this one. Where's your highest degree?
Top.
On top, which means no horizontal asymptote, right? None. But, so it's bigger on top, but the question now is it bigger on top? Is it bigger on the top than the bottom by 1?
Yes.
Yes, because the degree on the bottom is what? 1. And 2 is 1 more than 1. So that means we're going to have a slant asymptote. And guess how we get to solve that?
Plug in 1. Nope.
Long division.
Long division.
Let me tell you that this box does not look like it can hold all that long division.
Alright, so we're going to do division, but I said we're going to do long division. The reason I put long division, guys, is because a lot of times it's not just x plus or minus the number that we're dividing by. This one is one of the special cases. We're dividing by x minus 2. So if you wanted to, you actually could use your synthetic division to divide it. Alright, so let's do that on this one then. So I think we can squeeze it in here. So what number goes on the outside?
Your
2.
denominator.
2. What number is going to go on the inside?
2.
2, negative 3, and
5.
5.
And then 2. Holy crap.
So I end up with 2x plus 1 plus the 7 over x minus 2 when I do my when I do my synthetic division.
How did you get that last part?
Because it's our remainder is 7, and we always put it over what we divided by, which is the x minus 2.
So you wouldn't put it over just 2?
No, you have to put it over the x minus 2. So here's the thing, though, guys. We're talking about as we're going on to positive and negative infinity for my x's. So think about it. As the denominator gets bigger, what happens to your fraction? So let's do a little think bubble over here real quick. So like 1/2, 1/4, 1/8, 1/16. Yeah, your fraction's getting smaller. It's getting closer to what number? 0.
Oh.
Okay, because it's getting so small. It's not going to go negative, is it?
My bad.
Ma'am?
So it's not going to go negative, is it? No, it's just getting so small that we're going to say it basically zeroes out. So the nice thing is, because we're talking about going to positive and going to negative infinity, we know that that fraction piece is going to zero out. So we don't include the remainder. So our slant asymptote is going to be at y equals, and in this case we got 2x plus 1. So slant asymptote, you don't have to worry about the remainder, because in the end behavior, it's going to zero out. Does that make sense? I hope so.
And then we leave the slant in a y equals.
Yes, the slant is an asymptote. It's going to be a y equals, and guys, it's always going to be a linear line because your degree of the numerator is bigger than the degree of the denominator by 1. So it makes it a linear line.
So you're saying you just don't include the remainder portion?
Right, on the slant, you're not going to include the remainder portion. All right, so then we're going to go do our X intercepts. How do you find the X intercept?
You do something.
It's that numerator set equal to 0, right? So we already saw, though, that we couldn't factor it, so how else are we going to solve it?
Quadratic.
Yeah, we're going to have to use that quadratic formula. So let's fill that in.
No.
I think I remember this all over to it.
All right, so let's work this out. So we get 3 plus or minus the square root of 9 minus 40 all over 4. What's going on in that radical?
Negative.
It's going to be a negative, which means it's going to be imaginary, right?
Ew.
So can I have an x-intercept that's an imaginary number?
No.
No, so that means there's no x-intercepts. So I'm not going to worry about finishing that because that tells me there are none. And then we got to find that y-intercept. So I'm going to do that over here on the, squeeze it in on the left side. So to find the y-intercept, what do you do? X equals 0
0.
For just the top part?
for all of it.
So it's just 5 over.
Oh,
negative
for the whole equation.
So everything with 0 cancels, so you end up with 5 over negative 2. And if you want to put negative 2.5, you can, because that helps you with graphing it. All right, and we'll do our range and our end behavior there towards the end. All right, so let's graph our pieces here. So we have no x-intercept. We have a y-intercept at 0, negative 2.5. I have a vertical asymptote at x equals 2. All right, let's talk about that slant asymptote. I'm going to work this over here. So, there it is. So it's y equals 2x plus 1. How do you graph that?
Your y-intercept is +1.
Okay, your y-intercept is 1, which that's your starting point, right? And then your slope is?
Up to right 1.
Good, so up to right 1, or what if I can't go up?
Down to left.
Good, down to left 1. And remember, it's an asymptote, so it's going to be a dashed line, correct? So let's see, at 1, it's my y-intercept, and you said up to right 1. All right, and again, guys, it's never going to cross the slant asymptote, okay? The horizontal one is the only one it can cross, and that's only there in the middle. All right, so let's do our number line. And what numbers am I going to put on there?
2.
Just the 2.
What else would you normally put on it?
X intercepts and vertical asymptotes. So only 2 things that go on it.
Alright.
All right, so I need a number between negative infinity and 2.
0.
And we already did 0, and we got negative 2.5, right? So let's look at that. Now, as I go to the left, coming out of that negative 2.5, that slant asymptote is going to shape it. And as I come out of the right of it, that vertical asymptote is going to shape it. It's like a lopsided parabola, right? All right, so let's pick a number then between 2 and infinity. 3? Sure. All right, so we're going to plug this in. So we have y equals 2 times 3 squared minus 3 times 3 plus 5 over 3 minus 2. So that's what? 2 times 9 minus 9 plus 5 over 1. 18 minus 9 is 9.
14.
So 14 over 1, right? Which is 14. So the point 314. Now, and it's the same thing on the one on the bottom. I guess I should have specified. It can go above or below that point. We don't know how far. We just know then that somehow it's going to be shaped by these asymptotes. So this one actually may dip down. Whoa, almost dipped down a little too far there. And then come back up, okay? Or it may have come up at that point. We're not for sure, but it gives us a good idea. Now be careful on this other one, the bottom one, guys. It may have come up some more, but it's not going to cross that x-axis up there, okay? So it could have done something like that.
Would it have gone like almost all the way in the corner then?
Yeah, it's kind of in the corner area, yeah.
But it could go up a lot higher than that, right?
Yeah,
Okay.
yeah. We don't know for sure. We'd actually have to plot the points to figure it out, but we don't know.
Understandable.
All right, so tell me about the range.
Negative infinity to negative 2.5.
How long? Hold on.
Looks so good.
All right, guys, so actually our range on this one, we can't find it without our calculator. Okay? Because we really don't know how far down they go or how far up they go, do they? So let's actually just go ahead and omit this range this time. because we don't know how far up or down they're going. And then the end behavior. So we're just going to omit that. So I'll make end behavior be number 9. So tell me what's happening as my x's are going to the left. They're going to negative infinity. Well, I'm going to change this to blue here, and I'm going to trace over my line. As my x's are going to the left, what are my y's going towards?
Negative.
Negative infinity. And then as my x's are going to the right towards positive infinity, what's happening to those y values?
They're going.
Oops, wrong one. Sorry. Yeah, over here it's going to infinity. I didn't put my y. Y is going to infinity.